All right, part two of our discussion on paired versus two sample data. We've got an example problem at the bottom right here, and what I'm going to do is talk you through it without actually writing it down because I'm not going to be able to fit that all in this space right here, and it's just easier to talk through. So, depending on how you set up a problem, you can turn an experiment or turn a problem either into a two sample test or a paired test. It just depends on how you design it. So, let's go with two sample first. We want to see if I've got 30 volunteers right here, two classrooms available, and I want to know if kids perform better on tests, if there are no distractions in the room, or if there are distractions, like a teacher talking on a phone. So, two sample t-test first. What I would do in this problem if I wanted to make it a two sample test, I'd take my 30 people and I'd randomly assign 15 to each room. I'd have 15 people who are in the no distraction group, and I'd have 15 people who are in the distraction group. And what I would do is I would give those 15 people the tests, and I would basically compare how these 15 people, I'd average these 15, I'd subtract the averages, and I would see if, on average, the no distraction group did better. That would be a basic two sample setup. Paired test is maybe a tiny bit more difficult to think about, but I would basically take the same data set right here, and the way I could redesign it so it would be paired, I would take my 30 people. I would still do 15 for each room. So I'd have 15 people in my no distraction group. I'd have 15 people in my distraction group, and I would test them and see how they did. The difference here, instead of just like, oh, I would just compare my two averages and I would be done, I would afterwards swap them and I would do a second group, a second test. So I'd have like a second similar version of my test right here. And for my second test, I would do the opposite. So if you were in the distraction group, then you would be no distraction. If you were no distraction, you would be distraction. And at the end, I would take all 30 people's scores. Each person would have done the test twice, as opposed to the last example where it's just each person did one. And I would subtract whatever direction I wanted to, and I would get a score for each of my 30 people. And I would analyze those differences instead. Now, which of those two designs would be better? It would actually be better to do it the second way and do a paired data set. Why? Think about that for a sec. Why is it better to do paired? The answer is you're not eliminating, but you're accounting for the variability caused by just different people and their testing, like how good they are at testing and so on, and how distracted each individual person is. Do you have somebody who's very easily knocked off task, etc.? That all is taken care of if you compare each person to themselves. So that is what would be happening right here. You're accounting for that variability because each person to themselves is done. Now, in the first method, when I do a two sample, I have 15 people over here, 15 people over here. Maybe just by random assignment, I get more distractible people who got in the cell phone group, and that not ruins things, but it makes it harder for me to analyze my results. It is always better to do a paired test if possible. Now, it's harder to design a paired problem, so you don't always have that option. It also takes more time. I have to make two different versions of the test and make sure some people get it one version first, some people get the other. It's more work to do a paired test, but it's better in the sense that you're accounting for sources of variability. Each person is being compared to themselves. So when you have the option, paired is better. If you ran a paired test on this, I would expect to see a lower p-value just because those other sources of variability that may make our results cloudier are taken care of. Sometimes, though, you don't have that option, and you do a two sample test, which can work perfectly fine, but paired tests are better when possible. Final question down here, purpose of random assignments, more just a review question right here. I randomly assign to treatment or to which in this case, which test you go to, or in this case, which one you get first, to basically create roughly equivalent treatment groups to balance them out. And the purpose of the random assignment is to make sure I can conclude cause and effect, CE, cause and effect. If you make sure your groups are roughly equivalent and then there ends up being a difference between them, you can state that it's because of the factor that you are manipulating, in that being the distraction or no. So random assignment allows you to conclude cause and effect in your treatments.